Hello everyone. So before we begin with today's lesson, I suppose you remember from my previous video lectures that when light travels from a denser medium to a rarer medium, it bends away from the normal. And whenever refraction takes place, there is some partial amount of reflection also. So in this case here, we have two different media, denser medium and rarer medium. So this is the surface separating these two media. Here you have the source of light. From this source of light, light rays are going in all the different directions. So I have taken 5 such rays of light. This first ray of light is incident on the surface separating the two different media, and it is traveling from denser medium to rarer medium. Although when it travels from denser medium to rarer medium, the speed of light changes, but as it is incident normally, making the angle of incidence 0 degree, so it passes without any deviation. It goes straight like this. Another ray, if you see, so here the angle of incidence is 0 degree, here the angle of incidence is, let's say, I. It may be 30 degree, it may be 35 degree, like that. So here, as the light is traveling from denser to rarer medium, so it will bend away from the normal like this. So majority of light will be refracted, partial amount of light will be reflected. So this is the angle of refraction in this case. So again, if we see the third ray, here the angle of incidence is more than this one. So let's say this is the angle of incidence, and here as the light is moving from denser medium to rarer medium, so it bends away from the normal like this. It goes like this. And when refraction takes place, so there is some partial amount of reflection also. So light is reflected also. So again, if we increase the angle of incidence here, so obviously this angle is more than this one. So let's say at this angle of incidence, if the light just grazes to the surface separating the two different media, if the refracted ray goes like this from the surface, making the angle of refraction equal to 90 degree, then this angle of incidence in the denser medium will be called as critical angle. So I'll denote it by IC, critical angle, for the pair of media. And obviously some light is reflected also. So if you take another ray of light, so here the angle of incidence, obviously it is more than this angle, more than the critical angle. If the angle of incidence in the denser medium is greater than the critical angle, then the light is not refracted in the rarer medium, but the entire amount of light is reflected back in the same denser medium. It is called as total internal reflection. So here we have seen that as the angle of incidence in the denser medium is gradually increased, the angle of refraction also goes on increasing. And for a particular value of angle of incidence in the denser medium, the angle of refraction becomes 90 degree. This angle of incidence is called critical angle for the pair of media. And when the angle of incidence in the denser medium is greater than the critical angle, then the light is not refracted, but the entire amount of light is reflected back in the same denser medium. This phenomenon is called total internal reflection. Now, critical angle can be defined like this: the angle of incidence in the denser medium corresponding to which the angle of refraction in the rarer medium is 90 degree. So this angle is called critical angle for the pair of media concerned. If the denser medium be glass and the rarer medium be air, then in that case critical angle will have some value. That value of critical angle for glass and air pair, it is 42 degree. If it is water, denser medium be water, and the rarer medium be air, then in that case critical angle will be different. That means for different pair of media, critical angle will have different value. So here I have given one example. In the example I have taken critical angle for glass air interface, and it is taken as 42 degree. So these values can be calculated if we know the refractive index. When the angle of incidence in the denser medium is greater than the critical angle for the pair of media concerned, then the entire light is reflected back in the same denser medium. This phenomenon is called total internal reflection. In short form, we also call it as TIR, total internal reflection. In this experiment, we have a semicircular glass block and the light source. The light is allowed to fall on the surface separating the glass and air at different angles of incidence. You can clearly see that as the angle of incidence inside the glass block increases, the angle of refraction in air also increases. At an angle of 40 degree, which is the critical angle for glass-air interface, the angle of refraction becomes 90 degree. And when the angle of incidence is increased beyond 42 degree, the total internal reflection takes place. That is, the light is totally reflected back in the glass block. Now there are certain conditions when the total internal reflection, for the total internal reflection to take place. So ordinarily in all the situation, total internal reflection does not take place. Total internal reflection also follows the ordinary laws of reflection, meaning that in this case also angle of incidence and the angle of reflection will be equal. This angle of incidence and this angle of reflection, they will be equal. Now the first condition for the total internal reflection to occur or to take place is light must travel from a denser medium to a rarer medium. If this case condition is not followed, then total internal reflection will not take place. The second one is the angle of incidence in the denser medium must be greater than the critical angle for the pair of media concerned. Now since the critical angle also depends on the media and refractive index also depends on the media concerned, so there has to be some relationship between them. We'll try to establish the relationship between them. So here I have taken two different media. The denser medium is glass. I have denoted denser medium by D and rarer medium by R. So rarer medium I have taken air. So light is moving here from a denser medium to rarer medium. But since the angle of incidence here is equal to the critical angle, so that is why the angle of refraction becomes 90 degree. So the refracted light goes like this. It grazes to the surface separating the two different media. And there is some partial amount of reflection also. Now, here in this case, if we apply Snell's law, this is the normal, this is the angle of incidence, this is the angle of refraction. So if we apply Snell's law, then according to Snell's law, it is the ratio of sine of angle of incidence to the sine of angle of refraction, and that is equals to the refractive index of second medium with respect to first medium. So here, angle of incidence here, it is denoted by IC. So in place of I will write IC. And angle of refraction here, R is equals to 90 degree. So in place of R here, I am writing 90 degree. The second medium is air and the first medium is glass, because the light is moving from glass to air. So first medium is glass and the second medium is air. In place of the second medium, I am writing as air, first medium is glass. Now sine 90 degree is 1. Sine 90 degree is equals to 1. So in place of sine 90, I am writing 1. So here you have sine IC by 1 is equals to G mu A, that is the refractive index of air with respect to glass. Now if you apply this relation here, we have learned this in the principle of reversibility of light. If you have 1 mu 2, that can be written as 1 by 2 mu 1. So similarly, this G mu A can be written as 1 by A mu Z. So altogether you are getting sine IC is equals to 1 by A mu Z. So if you cross multiply, this A mu Z will be equals to 1 by sine IC. Or 1 by sine theta can be written as cosec theta also. So in place of 1 by sine IC, I have written cosec IC. So this one is the important relation. This relates refractive index of a medium with the critical angle of the pair of media concerned. That means if we know the value of critical angle for the pair of media concerned, then the refractive index can be calculated using this relation. If you know the refractive index, then critical angle also can be calculated. Now let's see that, how it is done. The refractive index of glass with respect to air is given as 1.5. Now you have to calculate the critical angle for a glass air interface or for a glass air pair. Then in order to find the value of IC, if mu is given, we'll follow the same relation. So since you know A mu z, refractive index of glass with respect to air, can be written as 1 by sine IC. So if you cross multiply sine IC, you get it like this. So sine IC is 1 by 1.5, because you know refractive index of glass with respect to air, it is given as 1.5. So sine IC is 1 by 1.5 is 0.66. So you can write sine IC is equals to sine 42 degree, because sine 42 degree, the value of sine 42 degree is 0.66. So in place of 0.66, you can write sine 42 degree. So altogether, if you compare these two, then you get sine IC, that is the critical angle for glass air interface, to be equal to 42 degree. So once you know this, similarly this type of problem you can do it yourself. So here refractive index of water with respect to air is given. It is given as 1.33. Then you have to find the critical angle now for the water air interface in the similar manner. Now let us discuss the factors affecting the critical angle for a given pair of media. Now the first factor is the nature of the medium. A refractive index for different media is different, and therefore critical angle for different pair of media will also be different. Now we know this relation. Refractive index of denser medium with respect to rarer medium is equals to 1 by sine IC. As the value of refractive index is different for different pair of media, therefore critical angle for different pair of media will also be different. If a medium is having low value of refractive index, then that medium will have higher value of critical angle. They are in a way inversely related to each other. Now the second factor is the color or the wavelength of light used. Color and the wavelength. You know, for the color of light, wavelength of light is the objective property, because for different colors of light, the wavelength of light is different. In the visible region, we have 7 different colors of light. We call them as Bibgyor or Roisebib. In the visible region, red color has the highest wavelength and the violet has the least wavelength. And the wavelength of other colors lies in between the red and the violet. Now critical angle for a given pair of media will be different for different colors or wavelength of light. We have the 7 different colors in the visible region. We can call this as Bibgyor or Roisebib. So if you come down like this, then the speed decreases in the material medium. That means in a material medium like water or glass, red light has the maximum speed and the violet light has the least speed. So in this order, if you go down, then inside the material medium, the speed of these colors of light decreases if you go down from top to bottom. Now let's say, so in a material medium like glass, speed of red light is maximum. So speed of red light is greater than the speed of yellow light. And the speed of yellow light is more than the speed of blue light. Now we know refractive index of a medium is given by this formula. It is equal to the ratio of speed of light in air or vacuum to the speed of light in a medium. So since speed of light in vacuum is constant, that is 3 into 10 to the power 8 meter per second, so this relation can be written like this also. That is, the refractive index of a medium is inversely proportional to the speed of light in that medium. If the value of particular color of light is more in a medium, then the refractive index of that medium for that color will be less. So since the speed of red light in glass is more, So therefore, refractive index of glass for red light will be less than that of the yellow light, and the refractive index of yellow light will be less than that of the blue light. Again, we know refractive index and critical angle are related by this relation, and I told you they are more or less inversely related. So therefore we can say, therefore according to this relation, critical angle for the given pair of media for red light will be greater than the critical angle for yellow light, and the critical angle for yellow light will be more than the critical angle for the blue light. During the day, the sand in the desert gets heated by the sun, and which in turn heats up the air layer close to it. And the air layer close to the sand becomes warmer. So as we go up, air layer gradually becomes cooler and cooler. Now this cooler air is optically denser than the warmer air. The light from the sun, when hits an object, the object in this case is a tree, it enters the first layer. As you know, first layer is cooler than the second layer. So first layer is optically denser than the second layer. So that is why refraction will take place. And on moving from optically denser to optically rarer medium, light will bend away from the normal. So similarly, at each layer, refraction takes place and light bends away from the normal until at some point the light is incident at an angle greater than the critical angle. So light, instead of undergoing refraction, it undergoes total internal reflection and reaches the eye of an observer. Human being perceives that the light travels in a straight line. So to this observer, this light appears to come from this point. So he sees the reflection of the tree under the tree, which gives him the false impression of pool of water under the tree.